Chapter 1.1.2.4 Namespaces. In Kubernetes, namespaces are used to isolate groups of resources within a cluster. Resources within a namespace must have unique names within that namespace, but not across namespaces. Namespace-based scoping only applies to namespaced objects like deployments and services, not cluster-wide objects like storage class and nodes. This allows for better organization and management of resources within a Kubernetes cluster. When to use multiple namespaces. Namespaces in Kubernetes are designed for environments with many users across multiple teams or projects. For smaller clusters with few users, namespaces may not be necessary. Namespaces provide a scope for names, ensuring resource names are unique within a namespace, but not across namespaces. Resources cannot be nested within namespaces, and each resource can only exist in one namespace. Namespaces help divide cluster resources among users through resource quotas. It's advised to use labels to differentiate slightly different resources within the same namespace, instead of creating multiple namespaces. In production clusters, it's recommended to avoid using the default namespace and create other namespaces for organization. Initial namespaces. Kubernetes has 4 initial namespaces: default, kubenode lease, kubepublic, and kubesystem. The default namespace allows you to start using your new cluster without creating a namespace. The kubenode lease namespace holds lease objects for each node to send heartbeats for control plane detection. The kubepublic namespace is readable by all clients and reserved for cluster usage. The kubesystem namespace is for objects created by the Kubernetes system. Working with namespaces. The admin guide documentation explains the process of creating and deleting namespaces. It is important to avoid using the prefix kube for namespaces, as it is reserved for Kubernetes system namespaces. To view the current namespaces in a cluster, you can use a specific command. To set the namespace for a request, the -namespace flag can be used. Additionally, you can save the namespace preference for all future kubectl commands within a specific context. These steps ensure proper management and organization of namespaces within Kubernetes. Namespaces. When creating a service in Kubernetes, it automatically generates a corresponding DNS entry in the form of service name, namespace named svc.cluster.local. This allows containers to easily resolve the service within the same namespace. However, if you need to access services across namespaces, you must use the fully qualified domain name, FQDN. It is important to ensure that all namespace names adhere to RFC 1123 DNS label standards to avoid conflicts with public top-level domains. To prevent unintended DNS redirection, restrict namespace creation privileges to trusted users and consider implementing third-party security controls like admission webhooks to block the creation of namespaces with public TLD names. Not all objects are in a namespace. In Kubernetes, most resources like pods, services, and replication controllers are in namespaces, but the namespace resources themselves are not in a namespace. Low-level resources like nodes and persistent volumes are not in any namespace. It is important to understand which resources are and aren't in a namespace in Kubernetes. Automatic labeling. In Kubernetes 1.22, the control plane assigns an unchangeable label called kubernetes.io/metadata.name to all namespaces, with the value being the name of the namespace itself. This feature helps to identify and organize namespaces within the system.